Hey everyone, in this video what we're going to do is we're going to find all values of k for which the given equation is solvable for real x. So let's begin by multiplying both sides of our equation by 2x plus 2. So we would have x squared plus x plus 2 is equal to 2x plus 2 all multiplied by k, which simplifies to 2xk plus 2k. And let's subtract minus 2xk and minus 2k from both sides of our equation so that we have x squared plus x minus 2xk plus 2 minus 2k is equal to 0. And let's just go a step further and factor out an x from the second and the third term so that we have x squared plus x multiplied by 1 minus 2k plus 2 minus 2k is all equal to 0. Notice here that we have a quadratic equation with the following coefficients: a is equal to 1, b is equal to 1 minus 2k, and c is equal to 2 minus 2k. What we're going to do is we're going to use the quadratic equation. Doing so, we have minus 1 minus 2k plus or minus the square root of 1 minus 2k all squared minus 4 multiplied by 2 minus 2k all divided by 2. Now, we're interested in the values of k for which our given equation is solvable for real values of x. So what part of this quadratic equation do you think is of interest to us? Well, the discriminant of the quadratic equation is what's of interest to us. So let's expand it. We have 1 minus 2k multiplied by 1 minus 2k minus 4 times 2 minus 2k, and that's equal to 4k squared plus 4k minus 7, which again is a quadratic equation with the following coefficients: a is equal to 4, b is equal to 4, and c is equal to minus 7. Now, let's look at the roots of this equation using the quadratic equation. We have our positive root, which we'll denote by k plus, is minus 1 plus 2 times the square root of 2 divided by 2, and our negative root, which we'll denote by k minus, is minus 1 plus 2 times the square root of 2 divided by 2. Sorry, they're both sounding very similar, but that's what the roots are. If we pay attention to the graph, or a graph that somewhat represents our quadratic equation, we have the following. Notice that between k minus and k plus, our quadratic equation takes on negative values, and negative values implies that we would have complex solutions for our first quadratic equation, because then we would have negative values under the square root sign. But we're only interested in values of k such that our equation is solvable for real values of x, right? So we want to avoid all values between k minus and k plus because they lead to complex solutions. So the values of k for which our given equation is solvable for real x are k less than or equal to minus 1 plus 2 times the square root of 2 divided by 2, and for k greater than or equal to minus 1 plus 2 times the square root of 2 divided by 2, which is the final answer to our problem. Thank you very much for watching. I hope you found this content useful. If you did, could you please make sure to like and subscribe? If you have any questions or problems you'd like to see get solved in future videos, leave them in the comment section below and I'll get back to you as soon as I can. Thank you very much. I hope you have a great day.